So folks, let's come to this part 18 video. Here we are going to look at the question, quite tricky and very important, and has been asked a number of times, and it's actually a little bit application based question. It's a good question actually. Let's see what it says. The question number 21, it says that does there exist a function which is continuous everywhere but not differentiable at exactly 2 points? Justify your answer. They have made the question really precise. So we have to give a precise example. They say that could you just state a function which is continuous, but it should not be differentiable. And differentiable, they give us a condition also that differentiable exactly at 2 points, it should not be differentiable. So you define a function such that it could be continuous, but it should not be differentiable, and that also exactly at 2 points. Now it's a beautiful giving example is a different art altogether. You need to know the functions really well, and you need to suit the requirement, whatever they say. For the example of a function which is continuous but not differentiable, a classic example for that is a modulus function. Modulus function is a continuous function but it's not differentiable. So obviously that modulus function is what is going to suit our requirement, but only thing, there is an extra condition coming up that it should not be differentiable exactly at 2 points. So you have to cater to that. So it's very clear to us that we are going to define a modulus function, but how? In such a way that, because modulus function, as I told you, is continuous, so it will suit that requirement. And then we have to take that function such that it should not be differentiable at 2 points. So we'll make that kind of choice as to how it is going to suit our requirement. So maybe if you could take a function like this, let f of x, let that function be something like, x modulus of x minus 1 plus x minus 2, something like that. Of course, this 1 and 2 is your own choice. You can take any point. Basically, you take any two real numbers such that you take the modulus as this kind of a combination. Why? Because they say that it should not be differentiable at 2 points. In order to suit that requirement, we are taking 2 points. The modulus, as a sum of two modulus functions. That's how we are taking. As I told you, 1 and 2 can be replaced by any number, or any real number. It can be 0, 1, it can be 5, 6, anything. So for example, suppose if this is the case. So we know that modulus function is continuous. So automatically sum of two modulus functions is going to be continuous, like that f of x is continuous. And how it is happening, we've already done in the continuity part. The exercise where we have done the continuity, there we have shown that mod x is a continuous function. So for further details, we can just refer back there, and then we can get ourselves convinced that it is modulus. So we'll just make a note. In the exam, we have to check the marks, and accordingly we have to write our steps accordingly. As per the demand of the marks, we have to elaborate on the steps. We know that modulus of x minus 1 comma modulus of x minus 2 are continuous functions. Therefore, modulus of x minus 1 plus modulus of x minus 2 is also continuous. As I told you, in the exam, we have to check the marks, and accordingly we have to show whether we have to show the continuity or not. We have to decide at that time. And if the way of showing, as I told you, we have already done in the exercise 5.1, where we dealt with continuity problems. We just have to follow that. So that's about the continuity. Now to check that it's not differentiable. So the points where the differentiability is going to create problem is at 1 and at 2. At these 2 points, it will not be differentiable. And in order to show that it's not differentiable, your standard tactics is to take the left differential and right differential and show that the left differential, right differential are not same, and hence it's not differentiable. So that's how we are going to do it. So let's take the left differential at x equal to 1. Let's start. Let's take the left differential at 1. Left differential at 1, you could give the definition, limit as h going to 0, f of 1 minus f of 1 minus h by h. So that way, limit as h tends to 0, f of 1 means you just substitute. That's quite easy. F of 1 means it's modulus of 1 minus 1 plus modulus of 1 minus 2 minus f of 1 minus h means in the function definition, wherever x is appearing, you have to put 1 minus h. So that way this will be uh, modulus of 1 minus h minus 1 plus modulus of 1 minus h minus 2. After all that, this is divisible by h. By h, this is by h. So let's try to now elaborate on all this. 1 minus 1 is 0, no need to write. 1 minus 2, modulus of 1 minus 2 is modulus of minus 1, and modulus of minus 1 we all know is 1. So also minus modulus of 1 minus h minus 1, minus 1 plus 1 cancelling, modulus of minus h. Now h is a very small quantity, something like 0.05, something like that, no, small quantity. Minus means it's a negative quantity. So obviously the modulus of it is going to be positive. So it's going to be h. So also 1 minus h minus 2. 1 minus 2, it's minus 1. It's minus 1 minus h basically. That means it's a negative quantity. So its modulus is going to be a positive value. No? So it's going to be like, it's going to be 1 plus h, because it's minus of 1 plus h. Whenever we take the modulus, we take the positive quantity. So it's going to be 1 plus h by h. Now let's see, there is a minus sign outside. So let's try to put it properly. Limit as h goes to 0. 1 minus h minus 1 minus h. When we take the minus, when we open up the bracket, the minus 1 plus 1 can cancel each other. Minus h minus h, it's minus 2h. So limit as h goes to 0, it's minus 2h by h. That can cancel. And in the limiting condition, the answer is minus 2. So the left differential answer is minus 2. Let's check what's the right differential and see how it goes. Therefore, what is the right differential at 1? Right differential at 1 by definition is limit as h goes to 0, f of 1 plus h minus f of 1 by h. Now f of 1, there's no need to do again because we have elaborately done it here and we've got the value. We've got that overall value for f of 1 is 1. So that we can take it up. Let's see what happens here. Limit as h goes to 0, f of 1 plus h, same way. In this definition, let's try to apply it. 1 plus h minus 1, 1 plus h minus 2. F of 1, we have got the value as 1 by h. So limit as h goes to 0, 1 1 cancel, modulus of h. H is a positive quantity, modulus of h is h itself. Now this is 1 minus 2 means it's minus 1. Minus 1 plus h. Now minus 1 plus h, it's a negative quantity. So obviously the answer is going to be positive of it. So you're going to get the modulus is going to be minus of minus 1 plus h. Now because whenever we take the modulus, we'll get its positive. So to make it positive, we have to give an extra negative to it. So that's how it is. Now let's try to expand and get it. Limit as h goes to 0, h minus into minus plus 1 minus h minus 1 by it's h. Okay, so what's happening here? You're getting h minus h 0, 1 minus 1 0, everything is 0. It's 0 by h, limiting value is 0. So what is happening here? You're getting the limit value as minus 2, here you're getting the limit value as 0. So because both the left hand and right hand limit are not equal, it is not differentiable at x equal to 1. We can conclude, therefore left derivative at 1 is not equal to right derivative at 1. So function is not differentiable at x equal to 1. Now it's a similar kind of steps for x equal to 2 also. So that we'll write similarly, but depends if you're in the exam, if it's a long question, no, so 6-mark question or 5-mark question, there you will have to elaborate and write everything. But otherwise, if it's a short question or very short question, you can just cut on the steps and write similarly. So that's how we will write similarly. It can be shown that f of x is not differentiable at x equal to 2. That's it. So this is the example which gives us a continuous function which is not differentiable at 2 points. That's all for this, and then the remaining problems maybe we can take it up in the next video. Thank you.